Alright, in this video you are going to learn how to use the ideal gas law. The ideal gas law is defined as PV equals nRT, where P stands for pressure, V is volume, N stands for moles, M is taken, so N is always given for moles. R is the ideal gas law constant, it is a value that never changes, and T is the temperature in the Kelvin scale. R will always be given to you. If you look down here, I have defined the variables. R is 0.0821, and the units associated with this particular ideal gas law constant are atmospheres, liters divided by moles times Kelvin. Those are the units for this number. Yes, it has 4 units, it's combined. But those are the units. Don't let that confuse you. R is always going to be this number, and I will always give you this value. You just need to now to substitute it in for this equation. T must be in Kelvin. So you can convert to Kelvin by simply adding 273 to the temperature given to you if it's in Celsius. If it's in Kelvin already, then you don't need to worry about it. So here's our set of instructions. For our example, we are going to use those instructions to help us figure out the answer. How many moles of hydrogen gas are contained in 2 liters, a 2-liter container, at 280 Kelvin in a 1.5 atmosphere? Alright, so we need to figure out what variables are given to us and what we're trying to solve for. We are looking for moles, and might as well give that the N. We are given a volume, we are given a temperature, and we are given the pressure. And R is the only variable left not written down here, and R will never change, it's always going to be this number. So our ideal gas law, at this point you have 2 options. You can go ahead and solve this equation for N, or you can substitute the values in and then solve for N that way. Either one will work, and it is a personal preference. Whatever one you choose should work for you. I am going to put the numbers in now. P is 1.5. The volume is 2. N is what we're looking for, so I'm just going to write N. R is 0.0821. And the temperature must be in Kelvin, and it is 280. So now we can solve for N. 1.5 times 2 is 3. Equals N 0.0821 times 280. It's going to be 22.988. And now we can solve for N, dividing by the number next to N. We'll divide by both sides. And that comes out to be 0.13. And N is moles, so remember to write your units in, and that's moles of H2. That's the basic idea for the ideal gas law. You won't always be solving for moles. You can be given any of these combination of variables and be asked to solve for the one that's missing. You'll always have R. So for example, you can be asked to solve for the pressure and be given the volume, the moles, and the temperature. Or any of the combinations. You can be asked to solve for temperature or volume, moles, or pressure, any of those 4. The basic idea is the same. Substitute in the numbers that you're given and solve for the unknown. And yeah, that's about it. All right. Thank you.